Hello, my name is Alina Bogumill, and this is my Unit 5 assignment. So the first measure we will be looking at is maximum frequency range. This parameter has to do with the flexibility of the voice while using typical connected speech. The lack of flexibility can result in a monotone sounding voice. So I completed this measure by recording myself reading the rainbow passage using Prot. I looked closer at a 7.2-second snip from this connected speech sample with varying levels of fundamental frequency. So if you look at the top image, the lowest my voice went was about 88.5 hertz. And if you look at the bottom image, the highest it went was about 335.1 hertz. So this demonstrated the typical frequency range for adults, which is generally 2.5 to 3 octaves. So the next measure we will be looking at is habitual pitch. This refers to the average pitch that a person uses while speaking. So to complete this measure, I use the same 7.2-second section of myself reading the rainbow passage used to demonstrate the previous measure. I checked the show pitch under the pitch tab. So if you look here, my average pitch level is right around 211 hertz. This is a little higher than the average adult female, which is around 200 hertz. The next measure we will be looking at is maximum phonation time. So this refers to the longest amount of time a person can say a vowel sound with one breath. The average healthy adult should be able to sustain a vowel sound for roughly 15 to 25 seconds. So to complete this measure, I recorded myself saying the E sound. And if you look at the image, this is my recording saying the E sound for roughly 17.03 seconds. And 17.03 seconds falls within that normal range of 15 to 25 seconds. So the next measure is minimum maximum intensity at various fundamental frequency levels. So a speaker with a normal, healthy voice should be able to vary his or her amplitude levels by 20 decibels to 30 decibels in the mid-range frequency when speaking. So a lack of this variability can result, again, in a monotone sounding voice. To complete this measure, I use the same 7.2-second section of myself reading Rainbow Passage used to demonstrate the first two measures. I checked the show intensity under the intensity tab. So in the top image, you will see that my lowest intensity level is around 51.11 decibels. And in the bottom image, you will see that my highest intensity level was around 76.79 decibels. So this falls within that 20 decibel to 30 decibel range of variance. So that would fall under the normal category. The next measure we will be looking at is periodicity of vibration. So acoustically, this is demonstrated in jitter, and typically jitter should be less than 1%. So if there is excessive jitter in the voice, it can have kind of a hoarse quality. To complete this measure, I looked again at that 7.2-second clip of myself reading the Rainbow Passage. I clicked on Show Pulses under the Pulses tab, and these are the little blue blocks seen on that image here on the left. So under the Pulses tab, I then clicked Voice Report, and if you look at the image on the right, this gave me data on several aspects, including the jitter in my voice. So the jitter in my voice as seen here is about 2.326%, which is definitely above the average range of less than 1%. So the final measure we will be looking at is noise generated by turbulent airflow. When something interferes with the vocal fold vibration, air flows through the glottis in a turbulent manner, causing a hoarse-sounding voice, essentially. So in the normal voice, the harmonic energy should be much higher than the noise energy. Otherwise, this additive noise can be heard. So to complete this measure, I looked at that same 7.2-second clip of myself reading the Rainbow Passage. I clicked on Show Pulses under the Pulses tab, and then again clicked on Voice Report. And if you look at the image below, this gave me data on several aspects, including my noise to harmonics ratio and harmonics to noise ratio. So, according to the Pratt manual, a harmonics to noise ratio of 0 decibels correlates with equal energy in the harmonics and the noise. So, my mean harmonics to noise ratio is at about 8.379 decibels, which is obviously more than 0, meaning that my harmonic noise is higher than my noise energy, which in turn shows that I am in that normal category for this particular measure.